Let's look at a couple more examples of calculations we can do with our formula for the future value of an increasing annuity. First of all, let's ask this kind of question. How much money do we need to deposit each month in order to reach a certain savings goal? So for example, if we are putting money into a retirement account over our working lifetime of, let's say, 30 years, and we want to have $500,000 in that account at the end when we retire, how much money should we put away each month if we're going to have an annual interest rate of 6%? Well, we have to figure out the quantities that we know to plug into our future value formula. We do not know the payment size. That's our unknown that we're going to try to solve for in this problem, how much money to deposit at the end of each month. We do know the future value. We know that we want to have $500,000 in the account when we're done. We know that we're going to make 360 payments. That's 12 payments a year for 30 years. And we can convert our annual interest rate into a periodic interest rate, dividing the annual rate by 12 to get the monthly rate. So plug all those quantities we know into the future value formula, and we can see that we want to solve for the payment size, and all we have to do to isolate PMT here is to divide both sides by this number. And that gives us PMT equal to 500,000 divided by whatever this quantity is. Type this into a calculator very carefully, and you end up with an answer of a little under $500, $497.75 per month. Okay, so this is how you could figure out the payment size if you know the other values. Another kind of question we could answer is, let's say we know the payment size, but we want to know how long it will take. So maybe it's a similar question like the previous one. We want to retire with $500,000 in the account, but we can't afford almost $500 a month. What if we can only afford to put away $400 each month? How long will it take in the same account to reach that savings goal? Well, let's figure out the values we know. This time we do know the payment size is 400 and the future value we're looking for is 500,000. We do not know the total number of payments we'll make. That's what we're going to solve for. And we have the same periodic interest rate as before. Plug the knowns into this future value formula, and we're going to try to solve for n. Now, n is in the exponent, so we expect to solve for it somewhere along the way by using a logarithm to get it out of the exponent. We will end up with an exponential equation we can solve at some point. But we have a few algebraic steps we need to take first before we're ready to do that. To isolate n, the first thing we should do is divide both sides by 400, and then we can multiply both sides by 0.05. Then I can add 1 to both sides. Oh, this is supposed to be 6.25, and this is supposed to be 7.25. And then we're ready to take logarithms of both sides. Now remember, the point of the logarithm is it allows us to bring this exponent n out front. And then we can isolate n if we divide both sides by log of 1.005, giving us a final answer of about 397.2. So it will take approximately 397 months, which is just over 33 years, to reach our savings goal.